Hi everybody, this is Mrs. GA, and today we're going to talk about segment length and midpoints. So before we learn how to find the length of a segment or the midpoint, we do need to do a little bit of vocabulary. So let's start with the word or the term point. So a point is just a specific location. So this can be in space or it can be on a coordinate plane, but we call it a specific location. And it looks like this. It's essentially just a dot, and it will be labeled with an uppercase letter, and that does matter. It's always going to be an uppercase letter. So there's only one way to name a point, and it's by writing point and then whatever letter corresponds with that point. So this one is not too tricky because there's only one way to name it. The next term you need to know is a line. So a line is a connected straight path. And a line will actually continue on forever and ever and ever. So you can see that lines have arrows at both ends, which means that it does continue forever. So another thing you will note with a line is that it will either have 2 points or it will have a cursive lowercase letter. And these are the different ways that you can name it. So one way you can name it is by writing the word line and then using the lowercase cursive letter. You could write the word line and you can use 2 points that are on your line. So you could say line VW. Notice that we need 2 points to name a line. You could flip the order. You could say line WV. It doesn't matter which order you use. Or if you don't want to write out the word line, what I'd recommend doing is you name the 2 points like this, and you draw a little tiny line on top. So you do need to have the 2 arrows, or you can flip the order. The order doesn't matter when you're naming a line. So you'll probably see me write it the most like this, but of course you can actually spell out the word line as well. So a plane is a flat surface that goes on forever. So this is how we draw a plane in geometry. I know it looks like it ends where these lines are, but that's just how we draw it. It actually would continue on forever. So think of a plane kind of like a sheet of paper that just continues on forever. So there are a few different ways to name a plane. So you'll notice this plane has 3 points on it, but it also has this tiny uppercase cursive letter here. So this is an uppercase cursive M. So that's another common thing you'll see in planes. So again, you can write the word plane and then say the cursive letter, or you can write the word plane and then you can name any 3 points on your plane. They need to be on your plane. Of course, the order of these doesn't matter. You can say plane ABC, CBA, BAC. It doesn't matter as long as you have 3. Or another thing you might see, if you don't want to write out the word plane, you can draw a little plane like this and then name 3 points on your plane. And again, here, the order of those 3 points doesn't matter. Okay, line segment. So you'll see that we have a line and a line segment. So the difference between these two is that a line goes on forever and it has arrows at both ends. A line segment is a portion of a line with 2 endpoints. So it specifically starts and ends at points. There's a few different ways to name a line segment. You can write out the word segment and name the 2 endpoints. You could write the word segment and flip the endpoints. It doesn't matter which endpoint you use first or second. The shorthand way to write these is the 2 endpoints with a line segment on top. Notice this does not have arrows. Or, of course, you can flip the order of the endpoints with your line segment on top. So make sure that your symbol matches your figure. And the last term you need to know is a ray. So a ray is a portion of a line that starts at a point but continues forever on the other end. So it's kind of like a combination of a segment and a line. So here we have a point and here we have an arrow. So the way that you name a ray, this one, the order actually matters. So you can write the word ray, and you're always going to start with the point and then end with the side with the arrow. So we'll say ray A, B, or the shorthand way to do that is A, B with a little ray over it. So again, for rays, we're always going to start with the point. So it starts here and it goes on forever in the other direction. Now I do have a few more pieces of vocabulary that we're going to start using, but not as much today. So the first one is coplanar. So this isn't an actual figure, it's a way to describe figures. So coplanar means that two figures are on the same plane. For example, you can have 2 points that are on the same plane, so we call them coplanar. Collinear means that the 2 points are on the same line. So again, these are just ways to describe different figures. Another way to describe a figure is by calling them parallel. So parallel describes lines that never cross. So parallel lines would look something like this. So you can see that if they continued on forever, they would never cross. And a segment bisector, this is our last piece of vocabulary, is a figure that passes through the midpoint, which is the exact middle of a line segment. So if you have a line segment like this, and we know that this is our midpoint, our exact middle, it cuts our segment in half. A segment bisector might be something that goes right through it like this. And again, we can tell it's a segment bisector because these 2 segments that it creates are equal. Okay, so here we're just going to practice naming a few different types of terms. I'm only going to list out a few options, but there's lots of different potential answers here. So here you can see a figure with a bunch of different types of figures. So first let's look for a point. So remember, point is essentially any dot. So some potential answers could be, we could say point U. We could say point E. You could say point B, you could say point H. Any of those are good answers, anything that is a dot. Now let's look for a line. So remember, a line has arrows on both ends. So I see 2 different lines here. There's a few different ways we can name them. So let's try this one. This one I can name 2 points, but it also has a little cursive letter here. So I can say line L. I can name this line by saying line BX, or we can use our little symbols, BX with our line on top. We could say BU, and that gives us this line. So any 2 points on this line will work, and there's many other answers that work as well. Now let's talk about the plane. That's this rectangular shaped figure. So again, one way I can name a plane is by picking any 3 points on my plane. So any 3 of these, pretty much the only point you can't use is X because it's not on your plane. So let's do point 8 or plane HBE. So that's one potential way. Or you might notice that this plane has the uppercase cursive letter here. So we can say plane S. Okay? Of course, there's other ways you can name the plane in this figure as well. Now let's find a line segment. So a line segment, remember, has 2 endpoints. So I can name this segment. I could say line segment UB with the symbol that matches what it is. Or I could say line segment BU. I could also use this as my line segment. I could say line segment HB. Or I could even name this as my line segment. I could say line segment BX. But remember, you do need to use 2 endpoints to name the segment. One thing to note is that BX can be a segment or it could describe the entire line. So make sure you have the correct symbol above. And last is array. So remember, array goes from a point to an arrow. So maybe we'll do this array, BH. Remember, you have to say the B first, and I can draw it like this. Or maybe I want to describe from here over, so I could say ray UH. I could say ray XB. Lots of different options here. Just make sure you start at a point and continue through the arrow. Okay, so now we're going to move on and talk about how to find the length of a line segment. So the length of a line segment will essentially just be the distance between the two endpoints, and for that we can use the distance formula. So the distance between any 2 points, x1, y1, and x2, y2, can be found using this formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, let's try one example together. So we're going to determine whether segments AB, which is right here, and CD, I'll do it in red, have the same length. So essentially we're going to use the distance formula to find the distance of each line segment and see if they are the same. So in order to do this, let's start by finding AB. I'm going to list out what the coordinates are. So I see A is at -4, +4. And I can see that point B is at 1, 2. So I'd like you to first list out the coordinates, and then I recommend labeling them x1, y1, x2, y2. So then when you use the distance formula, which I'll write again here, we can avoid mistakes when we're substituting. And I do recommend writing the formula every time. It does help when you're substituting the values in. Okay, so we have D equals the square root of x2, which is 1, minus x1, which is -4. Since I'm doing minus a negative, I'm actually going to add. So again, minus -4 is really +4. And then we're going to square that, plus y2, which is 2, minus y1, which is 4. And then we're going to square that as well. From here, we do need to follow our order of operations when we're simplifying. So we're going to start by simplifying what's inside our parentheses. So square root of 5 squared plus -2 squared. And now we're going to simplify our exponents. Remember, 5 squared means 5 times 5, so 25. -2 times -2 is +4. So here we have D equals the square root of 29. So now we need to find the length of line segment CD to see if they match. So let's list the coordinates. I can see C is at 2, 3. And point D is at 4, -2. So again, let's label x1, y1, x2, y2, and we're going to substitute it into that same formula. So we have D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So from here, let's simplify inside our parentheses. So we're left with the square root of 2 squared plus -5 squared. So the square root of 4 plus 25 equals the square root of 29. So you'll notice that our distances are the same. So that means that AB and line segment CD have the same length. Okay, go ahead and pause the video, and at this point I'd like you to try it on your own to determine whether segments EF and GH also have the same length. We'll check your answer in just a few seconds. Okay, so here you can see that I listed out the coordinates for EF and then GH. I labeled and I substituted my values into my distance formula. So line segment EF has a distance of square root of 26, while line segment GH has a distance of square root of 32. Since the distances are not the same, no, the lengths are not the same. Okay, I wanted to just take a moment to discuss a different way you can find the distance between 2 points, and that's by using the Pythagorean theorem, which hopefully we all remember is a squared plus b squared equals c squared, and it works for any right triangle. So this works really well if you have an xy axis like this with your 2 points on your graph. So what you're going to do is, if you have points UV, I connect them and then I turn this line into a right triangle by traveling over my horizontal distance and my vertical distance between the two. So you can see here I have a right triangle. So in this right triangle, we could call this A, we can call this B, and we can call this C. The important one is that C is always our hypotenuse. It's the one across from our 90-degree angle. A and B are interchangeable. So I can solve for this length using the Pythagorean theorem. So A in this case is going to be 1, 2, 3, 4, 5, 6 units. So A equals 6. Here I can count. I have 1, 2, 3, 4, 5. So B is 5, and then I can solve for C. So I'm going to substitute into the Pythagorean theorem. A squared plus B squared equals C squared. C is what we're solving for. 6 times 6 is 36. 5 times 5 is 25 equals C squared. And then I'm going to combine like terms here. So I have 61 equals C squared. And hopefully remember the inverse of squaring is square root. So I can take the square root of both sides and I get square root of 61 equals C. So that is going to be the distance between those 2 points. So again, this is just a different way you can find the distance between 2 points. However, it really works best when you have a coordinate graph to look off of. If you just are given 2 points, distance formula is probably the easier way to go. Okay, last thing we're going to talk about is the midpoint formula. So a midpoint is the point on a line segment that is in the exact middle. So it's halfway between the 2 points. So it can be found using this formula, x1 plus y1 divided by 2, and y1 plus y2 divided by 2. So you add up your x values and divide it in half, add up your y values and divide it in half, and notice it is an xy coordinate that we get. So here we're going to find the midpoint of line segment PG, which has these 2 endpoints. So we're going to find the midpoint and we're going to determine which quadrant it falls in. So here's a quick reminder of how we name the quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We use Roman numerals when we are naming quadrants. So I is 1, I is 2, I is 3, and IV is 4. And then again, this is called the x-axis and this is called the y-axis. Our point 0, 0 is called the origin. So sometimes our midpoint or another point will actually not fall inside a quadrant. It might actually be on one of your axes. So let's first list out the coordinates again of the endpoints. And I like to label them x1, y1, x2, y2. So when we plug them into our formula, we can avoid mistakes. So here's our formula again. So let's substitute. Here we have x1, which is -4, plus x2, which is 2, all over 2. And then we have y1 plus y2, which is negative 3 all over 2. And then we just simplify. We are going to make sure to simplify within our numerators first and then divide by 2. So here we have negative 2 over 2, negative 2 over 2. And simplify if you can. Of course, negative 2 divided by 2 is negative 1. So this is the midpoint of line segment PG. Okay, so now I'm going to have you pause the video and give this last example a try. Again, we will check in just a moment. Okay, let's check your work. So the midpoint between these two coordinates is 0, 2. So this is kind of a trick question. It actually doesn't fall in any of the quadrants. Since it's 0, 2, it's actually on your y-axis. All right, that is all for today. Thank you so much for watching. Okay, the last thing we're going to talk about is what is called the segment addition postulate. So this postulate says that if 3 points, so in this case A, B, and C, are collinear, meaning on the same line, and B is between A and C. Between doesn't mean the exact middle necessarily, it's just somewhere in this space. Then we can use the segment addition postulate to state AB plus BC equals AC. So really I think it's just common sense. It's really just saying a small part plus the small part equals the total big part. So we're going to use the angle addition postulate for these two examples. So let's read the directions together and then see if we can try number 11 together. So this says A, B, and C are collinear. B is between A and C. So I do want us to always draw what's happening. So we have A, B, and C. And again, we just know that B is somewhere in between. So whenever we're doing the angle addition postulate, I want you to start by creating an equation with your segments. So segment AB plus segment BC equals segment AC. And then we can use any given information and we can substitute. So if you set up the equation first, the substitution becomes much easier. So I'm color coding the parts that I'm going to substitute. So you can see first I'm going to replace AB with negative 1 plus 2x. So I'll do that in parentheses. Negative 1 plus 2x. Plus, I can see that BC can be replaced with 11 equals AC, which we are told is 3x plus 3. And now all I need to do is solve. So here I can combine like terms. We get 2x plus 10 equals 3x plus 3. Going to subtract 2x from both sides, so all of my variables are on the same side of the equation. And I have 1x plus 3, little inverse operation, and we get x equals 7. And the prompt did ask us just to solve for x, so we're done. So at this point, go ahead and pause the video and see if you can try number 12. Again, I would like you to always start by making a statement or an equation with the names of your segments. So we know again that this is the angle addition postulate. So do your substitution and solve. Okay, let's check our answers here. So I can see that we substituted AB with x plus 10, BC we substituted with x plus 14, and AC we substituted with 22. Then you're solving a linear equation here, and you should get x equals negative 1. Okay, we're going to try one more together. So here we're given a figure, and we're going to use the figure and the given information to find each measure. So here we are solving for x, AB, and BC, so different lengths. So for number 9, our only given is that AC, and this is point C at the end, this entire distance, and we can draw it like this, is 39 meters. So they would like us first to find x, and then again the length of AB and the length of BC. So I'm always going to start by making my angle addition postulate equation. AB plus BC equals AC. and now I'm going to substitute. I know that AB is 2x minus 8 plus BC, which I can see is x plus 17, equals AC, which we are told is 39. So now we can just combine like terms and solve to find x. So I'm going to combine these two terms and these two terms because they are on the same side of the equation, giving us 3x plus 9 equals 39. Inverse operation, 3 times x equals 30. One more inverse operation, divide by 3 on both sides, and we get x equals 10. So this is part of our answer, but they're also asking us to find the length of AB and the length of BC. So we're going to have to substitute. So first we see that the length of AB is 2x minus 8. And we can also see the length of BC is x plus 17. And we're going to substitute x equals 10 into both of those equations to find their lengths. So we do 2 times 10 minus 8, and then we just simplify. 20 minus 8 is 12. And here, let's substitute again. 10 plus 17, so we get 27. So again, the length of AB is 12 and the length of BC is 27. And then we can check to make sure that makes sense. 27 plus 12 is 39. So that all checks out. Okay, so at this point, go ahead and pause the video and see if you can give this problem a try. Okay, so let's check our answers here. So first, you should have set up this equation using angle addition postulate. DO plus OG equals DG. Small plus small equals big. Then we substitute our values and we solve for x. So we get x equals 7. Then to find the length of DO, we substitute 7 into 4x minus 3. And to find OG, we substitute 7 into 2x plus 21. All right, that's all for today's video. Thank you for watching.